Hello everyone. In this video, I'll be talking about conservation of energy and power. So, first of all, we can see the various forms of energy. There are various forms of energy in this universe. First we shall see is the heat energy. Heat energy is produced during various processes. For example, if we rub our arms together, heat energy is dissipated. Similarly, when a body moves on this surface which is having some friction, heat energy is dissipated. That is, some energy is lost in the form of heat. Now, chemical energy. Chemical energy is the energy which is possessed by the chemical compounds due to the binding of the atoms in their molecules. Chemical energy is the energy that living beings use to produce energy. Then there is electrical energy. Electrical energy is the energy which is possessed by the moving charges. That is electrical energy which is used to light our bulbs, fans, etc. Then there is nuclear energy. Nuclear energy is due to the energy mass equivalence as given by Einstein. He gave as the equation E is equal to mc square, where E is the energy dissipated, m is the mass, and c is the velocity of light in vacuum. There are basically two types of nuclear reactions which give out energy. That is the fission reaction and the fusion reaction. Fission reaction is normally used in our nuclear power plants to produce electricity, while the fusion reaction occurs in the sun. The sun produces its energy by the fusion of hydrogen atom. As the sun starts producing energy, the mass of the sun goes on decreasing. Hence, the mass is consumed to create energy. How? We can see the principle of conservation of energy. We have already seen that there exist many kinds of energies in this universe. But according to principle of conservation of energy, energy may be transformed from one form to another, but the total energy of an isolated system remains constant. That is, energy can neither be created nor destroyed. That is, energy can only be transformed from one form to another. Since the universe as a whole may be viewed as an isolated system, the total energy of the universe is always constant. If one part of the universe loses energy, another part must gain an equal amount of energy. That is, the principle of conservation of energy cannot be proved. However, no violation of this principle has been observed. This is very important. Now, we can see what is power. Power is defined as the time rate at which work is done or energy is transferred. That is, it gives the time rate at which a work is done. Power is a scalar quantity and its unit is watt. Now, the average power of a force is defined as the ratio of the work to the total time T taken. So, P average is equal to W by T. Now, instantaneous power. The instantaneous power is defined as the limiting value of average power as time interval approaches zero. That is a power at a very small time interval. So first we can prove that P is equal to dW by dt. As we have already seen, the P average is W by T. So in the case of a very infinitely small time interval, it can be taken as dW by dt. For displacement, dr and force F, work done W is equal to F dot dr. Substituting this, we get power is equal to F dot dr by dt. But dr by dt is equal to V, that is the velocity. Since velocity is given by the rate of change of displacement. So we have proved that instantaneous power is the product of force into velocity. So this is the end of this video. In this video, I have discussed some forms of energy, the concept of conservation of energy, principle of conservation of energy, and the important concept of power. If you have got any doubt in any of the concepts mentioned in this video, please comment in the section below this video. Thank you.